Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Harnessing Biomethane for Australia's Energy Transition. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Zinfra. Zinfra is a leading Australian infrastructure service provider to the energy industry, renowned for its operations and maintenance, engineering, construction and project management capabilities. With an impressive portfolio of successfully executed services and projects worth over Australian dollars 1 billion per annum, Zinfra combines technical expertise, innovative thinking, and robust safety protocols to ensure they safely and efficiently deliver on time and within budget. Committed to creating sustainable and forward-thinking infrastructure, Zinfra plays a crucial role in keeping Australia connected while powering the nation's transition to a future of renewable energy. Zinfra stands as a trusted partner in driving Australia's energy infrastructure forward. Today, we will hear from 3 speakers, followed by our live audience Q&A, and I encourage you to send questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Philippa Minton, Market Development and Strategy Manager, Gemina. Philippa is in the renewable gas team at Gemina and tasked with accelerating the uptake of renewable gases such as biomethane and hydrogen in Australia. Philippa and her team work with customers who will require renewable gases, project developers who want to produce renewable gases, and policymakers to help enable the industry. Please welcome Philippa Minton.
Yeah, thanks for having me. So today I'm going to set the scene in terms of where we're at in the biomethane market for the Australian context and give you a bit of a lead into where the Australian market's at, where the international market's at, and where we think we can go to with biomethane. Firstly, though, I just want to introduce Gemina at a group level. So we're a $12.4 billion major utility infrastructure owner. Our largest asset is the Gemina Gas Network, which sits in New South Wales and services around 1.5 million customers. We also own gas transmission pipelines and an electricity network in Victoria. Gemina employs over 3,000 people, and we've got over 2,000 kilometres of gas transmission infrastructure. Zinfra is the services arm of the Gemina Group, and they deliver engineering, project management, construction operations and maintenance services to Gemina, but also other Australian energy infrastructure companies. So as a major utilities infrastructure owner and investor in gas networks, we have a very big vested interest to ensure gas can become decarbonised by 2050 and beyond. We believe that to decarbonise natural gas, there'll be 3 main renewable gases that will need to be utilised. The first, and what we're going to go into detail today, is biomethane. So I'll start with the other 2. Green hydrogen, I think this audience will be very educated on that, but it's when you take renewable electricity and water and you split the water molecule into hydrogen and oxygen. That hydrogen is therefore considered renewable and also zero emissions. Green hydrogen will play a major role in the decarbonisation of gas, but maybe we think in a different way to what might be understood. From a network perspective and in the short to medium term, we're looking to blend hydrogen into our network at around 10% blend rate. This is what's currently approved for us to do into our distribution pipelines. The reason that we use a 10% limit is because this is where it becomes a drop in fuel for our downstream customers. Therefore, no changes are required on their end and they see no differences. The second fuel that I'll discuss is synthetic methane. So, this is where we think the majority of green hydrogen will be utilised in terms of decarbonisation of gas networks and gas infrastructure. Synthetic methane is made by utilising green hydrogen, using biogenic CO2, methanating them to create more methane. So, effectively, it's just another drop in fuel that is low emissions when compared to fossil natural gas. We believe that synthetic methane will come into the energy mix further down the track, and that's because it needs time for green hydrogen production costs to decrease, and then the methanation step as well on top of that. So now we'll get into biomethane. So biomethane is created when organic matter decomposes or digests. Typical organic matter that is used is from landfills, and that utilizes food and garden organics, wastewater, which effectively utilizes human waste, agricultural residues, so crops, or animal effluent waste, so waste coming from animals. What it does is then takes that organic matter and it puts it into anaerobic digestion. Anaerobic digestion is where all of that organic matter is then broken down to create what we call biogas. And biogas is a mixture of methane and biogenic CO2 and some other impurities. So the process to create biomethane is then after that, where you clean up the biogas, you take the methane and you use it as a drop-in fuel in the network. So one of the main questions we get is if biomethane is simply a methane replacement. When I turn on my stove at home or when we combust it in boilers, we still have carbon emissions. So therefore, how could it be a zero emissions fuel? And the answer to that is the biogenic carbon dioxide cycle. So carbon dioxide that originates from decomposition, digestion, or combustion of biomass is considered biogenic. And what that means is it's part of the natural carbon cycle where CO2 that is released is then reabsorbed by biomass through things like photosynthesis. And it's different to fossil fuel CO2 because fossil fuel CO2 has been stored for millions of years, unlike biogenic CO2 that is considered part of the short term cycle. And this is how it cannot be carbon adding, but instead carbon neutral. So, by utilizing the natural carbon cycle, you get a lot of circular economy benefits when generating biomethane. Firstly, and most prominently in gas networks, you get displacement. So, no longer do you have fossil methane in your pipes, you get it displaced by biomethane. There's other emissions benefits, though, also. The first is the digestate that is created as part of the anaerobic digestion process. So, as discussed before, anaerobic digestion creates biogas, but that organic waste also has what we call digestate left at the bottom. This can be a great decarbonisation option to replace fossil fertilizers. And it's circular because you have the organics coming from places like farms and cropland, it's delivered, and then the digestate can be returned to land. You also have biogenic carbon dioxide as part of the anaerobic digestion process. So this biogenic carbon dioxide is taken, is removed when you're doing the upgrading process, and then the biogenic carbon dioxide can be utilized, cleaned up, liquefied to replace fossil carbon dioxide uses. And the one we often draw to is the bubbles in your drink. So that's typically the CO2 in drinks comes from fossil sources of CO2, so it can be replaced by biogenic CO2. So now we know that biomethane is a low emissions fuel, a drop in fuel, so therefore no downstream infrastructure changes on the customer side. we might start to think, how hasn't this industry evolved in the Australian context? And it's a very good question. So, internationally, biomethane is far more advanced than in Australia. Starting with the United States, now they have around 2,300 biogas facilities and then about 280 biomethane facilities. A lot of that biomethane is used in California due to policy settings to displace fossil fuels. The other major market is the European market. So in Europe, they have a goal to create 35 billion cubic meters of biomethane by 2030 throughout the EU. They have countries that are really leading the way, ones like France, Germany, Denmark. Denmark currently has 34% biomethane running through their networks, and they endeavour to have 100% by 2030. Italy's network is currently transporting over 11% biomethane. Now, the EU had a bit of an advantage, and that was because that was largely triggered an exponential growth for the biomethane market by the invasion of the Ukraine, by the invasion of Russia into the Ukraine and getting off Russian gas. So that's where we saw really big targets start to eventuate throughout the European Union and the United Kingdom. The United Kingdom market's also interesting. They've got over 80 biomethane plants connected to the grid, and places like Ireland have 100% biomethane ambition by 2045 through their gas network. So what we can see is it's a fairly established market internationally, but still we don't see a market here in Australia. And why is that? Because we're really far behind. So, from an Australian context, how much biomethane do we think we could actually produce is a really good question to start with. There's been some misinformation out there that it's too small to bother with in terms of the energy transition. However, the bioenergy roadmap stated that by 2030, bioenergy, all encompassing, including biomethane, could generate 10 billion in GDP, create 26,000 new jobs, a lot of those largely in regional areas, and also have a 9% reduction in emissions, on Australia's emissions. For context, natural gas consumption is estimated at around 913 petajoules per annum across Australia, and the theoretical and recoverable biomethane potential is around 563 petajoules. So, in no kind of short form is this a small solution to the decarbonisation of gas. It's very significant, and biomethane will play a large role in the energy transition. As can be seen, different states have different potentials for biomethane creation, with Queensland and New South Wales and also Western Australia being significant states in terms of their energy potential. From a New South Wales perspective, which is where our Gemini Gas network sits, we believe that we could decarbonise uh, over 88 petajoules economically. So, looking at our network as a total, we transfer about 90 petajoules per year of gas to our customers currently. So, we believe it can be extremely significant. So, if we say that it's got a lot of potential in Australia and it's happening overseas, what's happening in terms of Australian policy to not allow this industry so far to have moved forward? So, the renewable gas policy landscape is lagging a lot. And for context, the renewable electricity transition pretty much started in 2001 with the renewable energy target. So, therefore, the decarbonisation of electricity when compared to gas in the Australian landscape is about 24 years ahead. However, in the last few years, we are seeing a lot of traction in the renewable gas market. Historically, there was a lot of support from about 2019 onwards for green hydrogen, and it was seen as the renewable gas that was really coming forth and was going to be large for the Australian economy and from an export point of view. We've seen some of that heat come off that industry lately, and that's because the costs haven't come down as fast as what was originally thought. So, at a federal level, there was the National Hydrogen Strategy. There was also state based strategies in a fair few of the major states for hydrogen production. So, what's happening now is governments are slowly tilting from that hydrogen outlook more into renewable gases in general. So, they're not saying that hydrogen doesn't have potential, they're just saying it could be further away and other renewable gases and renewable fuels could be faster coming into the economy. From a New South Wales perspective, the current government is looking at a renewable fuel strategy, and it's actually due to drop any day now, mid 2025. So, under that renewable fuel strategy, we're expecting to see some support for biomethane to really start trying to kickstart the industry. Currently, in New South Wales context, we have policy targets to produce green hydrogen. And what we expect to see in that renewable fuel strategy is the expansion of those hydrogen targets to other renewable fuels, including biomethane. The target for hydrogen sits at 8 petajoules per year by 2030, and we hope to see that expanded to biomethane and that target to be even greater. We believe that that ambition at a New South Wales state level, which is once again where our network sits as Gemini, will be a really big catalyst to start this industry. From a federal level, what we're seeing is the future gas strategy. So, the future gas strategy came out and effectively gave gas a license to continue to operate, but called out the fact that it will absolutely also need to decarbonise, and renewable gases will be the way to do that. As we know, gas will play an important role in the electricity energy transmission in firming renewables. So, from a biomethane market perspective, there's some things a market fundamentally needs to be able to progress forward. What the Australian market didn't have until around 2 years ago was a renewable gas certification scheme. So, what that means is even if in Australia you created biomethane and you injected it into the network, downstream customers couldn't say that they were decarbonising using that gas. But what we have now is two paths forward for that. The first is the Green Power Renewable Gas Guarantee of Origin scheme. So this scheme certifies biomethane, and it came into fruition in 2023. And what we will hear from Jared later is that the Malibar Biomethane Project, which is the only project in Australia, was the first to be certified under that scheme. The second and probably publicly more well known is the Guarantee of Origin scheme. So, a Guarantee of Origin scheme effectively tracks emissions from, depending where it is, largely cradle to gate, and it tracks the life cycle emissions of a fuel or a low carbon embodied good, so that you can get the emissions reduction benefits associated with products. And it's a large part of the Future Made in Australia bill that sits at federal government levels. That Guarantee of Origin scheme is currently about to start from a green hydrogen perspective, and we expect in the next year for it to be expanded to biomethane. The work is currently undergoing. So, once you have certification, those certificates can be used by a voluntary market. So, people that want to buy those certificates and surrender them for their own decarbonisation purposes. But it also is better if it's actually recognised under mandated schemes. So, from a mandate point of view, in the Australian context for decarbonisation, the pretty much only mandated scheme is what we call the safeguard mechanism. So, the safeguard mechanism encompasses around 215 of Australia's largest emitters, and it says that they have to decarbonise by 4.9% emissions from their baseline emissions every year. And that's their scope 1 emissions. And we all know natural gas is a large constituent of industrial scope 1 emissions. So we believe that biomethane will play a really fundamental role in terms of the safeguard mechanism. And possibly one of the biggest policies that we need to come out is the recognition of biomethane under the NGES scheme. And that's due to begin on the 1st of July. So from the 1st of July, those safeguard entities can buy renewable gas certificates and surrender them and see the decarbonisation potential. And what that also brings is the decoupling of the gas molecule with the certificate, very much the same as the electricity network. So it won't matter where the biomethane is put into gas infrastructure on the East Coast, someone else on the East Coast will be able to buy that certificate for the green premium and surrender it. Therefore, you no longer need a physical link or to be behind the meter and consuming the actual biomethane molecule. You just can consume natural gas from the network and take the green credentials, the same as the electricity network. So, what that tells us is we think that there's really big things to come from a biomethane potential industry. We're seeing large investors looking excited from this as an industry. And what it does is it offers new jobs, but new jobs in areas that don't require much skill difference to existing areas. And that's what we're doing at Gemini and what Jared can talk to a bit later. And that's our Malibar biomethane plant, being able to upskill people that were traditionally in fossil natural gas industry and giving them a future in the renewable gas industry. So now I'd like to pass over to Jared, who's going to talk more around our biomethane project as in Gemini. And once again, it's the only Australian project. Thank you.
Thank you, Philippa, for a great presentation. I'd now like to welcome our second speaker, Jared McKins, Project Manager at Zinfra. Jared delivered Australia's first biomethane project to inject into the gas distribution network, Gemini's Malibar biomethane injection plant in 2023. Jared continues to provide support at Malibar in implementing operational efficiency, and his advocacy for sustainable construction practices underscores his holistic approach towards environmental stewardship and responsible project management. He is passionate about the growth of the renewable gas industry and active in Gemini and Zinfra's strategy for future opportunities in this space. Please welcome Jared McKins.
Thank you for having me today. I'll present some of the findings of the Malibar biomethane injection project. So I can start this off by telling you a bit about the Malibar project, and then I hope to give you a bit of a good understanding of how biomethane upgrading happens. With that, we can take some of the ideas and consider the design and delivery collaborations that we should consider in the future, as well as looking at these biomethane stakeholders and partnership and how they should collaborate for future deliveries. Summing it up, we'll take those key takeaways and look at whether we can take the bioenergy industry going forward. So the Malibar biomethane injection project is located in the eastern suburbs of Sydney. It's a collaboration co-funded from Gemini and the Arena Industries, as well as working with Sydney Water inside the Malibar Water Resource Recovery Facility to deliver the project. So it was the first renewable gas injection that went to a network in Australia. So it's a pretty exciting and novel technology that we got to implement. So the wastewater resource recovery from Sydney Water, it was selected because it has one of the largest catchments for the Southern Hemisphere. It's pretty much a collection of about 1.8 million people delivering into a water outflow facility. And they had some existing infrastructure using the biogas and the anaerobic digester products. So they were producing cogenerated electricity on site as well as producing digestate production. Even after biomethane, they still continue to generate cogenerated electricity, which we partially use as on site as well. So the process starts from the wastewater. It's collected, the solids are collected and sent to an anaerobic digester. The anaerobic digester, it's a process where organic matter decomposes naturally under wet conditions. It's deprived of dissolved oxygen, allowing a biochemical conversion to occur for the microorganisms. So this happens, the hydrolysis splits complex organics into simple organics, such as the proteins, carbohydrates, and fats. Acidogenesis allows those simple organics to break down further into, I guess, fatty acids, and you start to populate CO2 and hydrogen gases. And then acidogenesis, which allows those short chain fatty acids to acidic acids, more CO2 and hydrogen. And then that final step, which is the methagenesis, which allows those CO2 and hydrogen to naturally form into a biogas. In the end, we end up with a biogas as well at about 60% CH4, 40% CO2, and other contaminants. Also, the anaerobic digester, as I mentioned, produces out a biosolids or a digestate, which is used for various applications. So down upstream of the biomethane upgrading facility, a number of other infrastructure are utilising the biogas as well. So Sydney Water, as I mentioned, are using it for co-generated electricity, and we had the waste gas burners in there as using a protecting anaerobic digesters and removing the biogas product to sending it to atmosphere. So our objective of the upgraded facility was essentially to become the waste gas burner zero and take all that excess biogas and deliver it into our facility. So we receive a 1,200 standard cubic meters at about 2 kPa at 35 degrees. It's 100% saturated. It has H2S up to about 1,200 ppm and various other contaminants such as siloxanes and VOCs. So I guess where we've got a challenge here is that we've got a biogas product at a low pressure, and managing that into the production and achieving the most efficiency out of that, we installed the buffer storage system. So essentially this allows for erratic pressure fluctuations that occurred due to the upstream devices such as the cogen level switches and waste gas burners protections. So we are able to capture that into a pressure reservoir, which absorbs those fluctuations and maintains a more stable pressure profile. So this is an optimum position for us to measure and set the performance of our facility. Downstream from here, we have a compressor, and it's controlled by the level switch of our buffer storage system. Okay, so the biogas, the first part of our pre-treatment that we need to do is that we need to dehydrate and remove that condensate. A simple application that we use to remove this is sending the biogas through a heat exchanger, dropping that temperature down to about 5 degrees, allows that condensate to drop out, and it's sent back into the Sydney Water's wastewater treatment. So now I've got a dry gas, so I increase its pressure to about 11 kPa so that I can send it through our granulated activated carbon for removing the other contaminants. So as I mentioned, about 1,200 ppm and H2S. This is probably the upper limit of where granulated activated carbon is an effective technology. Above this, you start considering other applications such as chemical scrubbers or biological amine systems as well. Here we have, as I mentioned, the granulated activated carbon. We have a lead lag system in the first two vessels that have a impregnated carbon. Typically, you use a caustic-based system to target some of these contaminants, in particular the H2S. Our third vessel is a natural granulated activated carbon, which is focusing on removing the remaining elements such as the VOCs and siloxanes. This is where we start to really distinguish between the natural gas and renewable gases as well. The current amendments that are looking at the AS 4564/24 for our regulated natural gases, we start to include how we're going to control the biomethanes contaminants. We start addressing areas such as ammonia, semi-VOCs like limonene, which has the potential to mask deodorant, halogens, fluorines, and chlorines, which are hazardous to human health and the integrity of our gas infrastructure, as well as the siloxanes. Siloxanes exist and combusted can lead to an early failure of gas-fired appliances. This is important to ensuring that our customers ensure that they feel comfortable using a regulated gas, and important that we treat these. Not all anaerobic digesters or feedstocks are going to produce the same contaminants, and it's important that as we identify our feedstocks, that we're identifying relevant pre-treatment technologies to manage these. Downstream of this, our next step where we're going to remove our CO2. For this to happen, we need a compressor gas. We run it through a 400 kVA electric motor-driven screw compressor, moves our gas from 0.1 to 16 bar. As I mentioned, this device is driving our production of the facility, and we've set the control switch of this from the level gauge of the buffer storage system. At 16 bar, we're able to now send it through our membranes. The membranes are a hollow fiber membrane that allow for gas separation. So it allows that biomethane to stay within the fibers, and the CO2 will permeate outside of it. Combining this with the three-stage membrane process, we're able to get that 99.5% methane recovery. Three-stage essentially means that each of the exit sources are retreated, and the remaining product out of that is sent back to as a recycled biogas. We compress it and we send it through our system again. Currently, like the CO2, we know it is a commodity. There are industries out there that rely on it. We have seen it being used in a lot of European applications. Currently, the Malibar project doesn't utilise the CO2. It is sent to atmosphere, but yeah, it is noting that it is that commodity. It is something that you need to consider. Where does it get used in applications? And it'd be good to see where the next steps are with biogenic CO2. And finally, we're left with that methane stream. So essentially now we've got what we would expect to be a biomethane product that's the equivalent to ready to go into our network. So the way that we're going to determine this is that we have a number of quality control processes using gas analyzers and gas chromatographs that take quantitative and qualitative measurements throughout the process, and we meet the requirements that are required for our natural gas to meet the criteria to go into a regulated gas network. So once we are able to determine that it meets that network, that gating control valve is able to be open and send it to the network. If off-spec gas is identified, our next step is that valves get closed, it gets recycled through the system. This means that we're not venting any off-spec gas and ensuring that we can achieve as much production as we can out of the facilities. Meanwhile, our equivalent product, the renewable gas that's ready to go to the network, we give it a squirt of a McKins liquid, which is required for many gas networks. And here it's able to be injected into the Gemini gas network. The gas network is a 1050 kPa distribution network, and the renewable gas is blended in here where it's indistinguishable from the natural gas. Now that I've given you that good idea of how biomethane upgrading works, I'm hoping that I can share you with some of the considerations that you probably need to start thinking about if you're planning to utilise biomethane upgrading technology. So where we see this infrastructure exist in Europe, it's centralised within the anaerobic digester process. That heat recovery from compressing biogas is perfectly good to be used onto the anaerobic digester, similar to how the cogens work. It also removes that level of protection between the low pressure storage system and isolation valves where you would just integrate the production of a compressor onto the anaerobic digester lid. Other sensible decisions that we would consider is the shared pre-treatment. I've mentioned the siloxanes and how harmful they are in combustion to operating equipment. So therefore, like considering using a granulated activated carbon process to remove those in earlier stages, or if H2S as well is also vulnerable to equipment due to corrosion, that you start treating that earlier on in the process for the holistic approach of treating biogas. And then at that final stage is around that operational challenges. I guess, if anybody's a process engineer out there and dealt with challenges of trying to optimize those the level switches, imagine trying to set 4 or 5 level switches at half a kPa. It's very challenging to optimize that, and it always leaves you vulnerable to having to rely on protection systems of waste gas burning to remove it. So the better that we can optimize that, the better that we can improve our production. All right, and then I guess now you might have a sense of it's not just like a one industry application. The biomethane or bioenergy provider or supplier doesn't exist in Australia at the moment, and I don't think that they're one industry alone. I think it's a combination of a number of partners. I see the agriculture, waste and water, gas all combining together to get as much as they can in terms of sustainability out of this process. Agricultural companies, industry is going to be looking for the alternative and a renewable or a digestate that meets and returns to their industry as they provide feedstocks themselves. Considering it the CO2 as a source for it's not just limited to the food and beverage industry, but it can be applied into other applications such as abattoir or injected into greenhouses to promote growth. In the wastewater industry, we see improving operating life of equipment via shared pre-treatment, utilising the upgraded heat transfer for the anaerobic digester process, and sharing of parasitic electricity for biomethane upgrading as well. In the gas industry, we see that there's going to be, we've got customers that don't find it as easy to electrify their equipment as others. They're going to rely on a natural gas or renewable gas product to assist them in the decarbonisation process. We'll need to consider diverse energy markets. I mean, standalone and putting all your eggs in one basket leaves us exposed to other risks, and diversifying that portfolio would be essential. So it's the continued debate of molecules for electrons in energy storage. We've got numerous pipelines and transmission assets of gas transmission assets all up the East Coast that's act as essentially molecule batteries. Be opportunistic for us to continue to use those. And again, optimizing our gas networks. The Malibar biomethane injection project is one of the first gas production facilities for New South Wales. So for the people of the Sydney eastern suburbs area that are using a close source produced renewable electricity means that there's a far more optimized transportation of that energy from source to their applications as well. I guess, like, to sum it all up, I guess the key takeaways would be this is technology that's proven, it's scalable, it's integratable. It's been existing in Europe for over 30 years. We just need to adjust it and make it suit what's important for Australia. That partnership, I said, it's key to unlocking that circular economy. The biomethane product alone is just a small fraction of the efficiencies that we're meant to get out of this process. And then my final thought is that, like, bioenergy, it's going to be a combination of numerous industry partners. So I guess the more that we can collaborate, means that more we're going to be considerate of our partners and sharing, I guess, the growth and the welcoming of bioenergy into an Australian market. So I guess thank you very much for letting me present, and I'm looking forward to answering a lot of questions at the end of this webinar. Thank you.
Thank you, Jared, for your presentation. I'd now like to welcome our final speaker, Rahul Daraj, Manager, Environmental Operations and Carbon Accounting at Gemini. Rahul was the Sustainability Manager for the construction of the Malibar biomethane injection plant and was tasked with embedding sustainability initiatives aligned with infrastructure sustainability ratings during the construction phase of the project. The project was awarded a bronze rating from the Infrastructure Sustainability Council and is the first energy project in Australia and the first project in New South Wales that has been certified under the Infrastructure Sustainability Essentials Pilot Rating Scheme. Please welcome Rahul Daraj.
Good day, everyone. Thanks for dialing into the webinar. I am Rahul Daraj, Environmental Manager for Zinfra. Today I'm going to talk about the Infrastructure Sustainability Council rating that we obtained for the Malibar Biomethane project. So, Infrastructure Sustainability Council is a rating agency that is very well recognized in Australia and in New Zealand, and as part of that, we registered Gemini and Zinfra registered this project for obtaining an IS Essential rating for the project, and we ended up receiving a bronze rating for the project. The two highlights is that this is the first project in New South Wales to achieve an IS Essential ratings in New South Wales, and also it's the first energy project in Australia to receive an IS Essentials rating. And we go into the blueprint of how we ended up receiving the bronze rating for the project, right? So initially, we had a kickoff meeting with ISE, wanted to know what's the approach on signing up for this infrastructure sustainability rating. And as part of that, by the time we reached out to them, unfortunately, the design phase of the project was already completed. So we could only sign up for this rating scheme for the construction phase of the project. And we actually signed up for this rating scheme voluntarily. It was not a development consent that was put on us, like for a lot of major projects, road and rail projects. It's a mandatory obligation that you need to sign up to this IS rating scheme. However, we did it in voluntary basis, right? The next one, following us signing up for the IS rating, we did a workshop, Infrastructure Sustainability Council workshop, and that workshop goes into the detail of the materiality assessment that are relevant for the project. Yeah, any sustainable initiatives that are relevant for the project. Right. And during that workshop, we included internal stakeholders, members from ISC to help us identify the key sustainable initiatives that are relevant for the project and that can have meaningful positive contribution to the sustainability initiatives on the project. Now, during that workshop, key sustainable initiatives were identified, and as the next step, when the project went into the construction phase, we initiated the key initiatives that were identified during that materiality assessments workshop. Not only that, there were some on-ground improvements that were done during the construction phase of the project, and that were also implemented during the project. I'll go to the next slide to talk about what are all the initiatives that were implemented, some of the key initiatives. This is not the exhaustive list. This is the key initiatives that was implemented during the construction phase of the project. So some of the key improvements included recycling of off-specification biogas, avoiding the need for importation. What that means is that if for whatever reason the biogas, once it's processed, it does not meet the specification of biomethane to be injected into the gas transmission network, we redesign the equipment in such a way that the gas gets recycled and it does not get vented out to the atmosphere. So that's an initiative and improvement that was done during the construction phase of the project. Even though it's a design change, we implemented that. So that's contributed to reduction in overall emissions during the operations phase of the project, right? And use of engineered fill during the construction of the project. And we also procured LGCs, which is the large scale generation certificates for the electricity consumed, for some of the electricity consumed during the project and also during the operation phases. The next one is the material use reduction. We achieved an 18% reduction in material footprint during the construction phase of the Malibar biomethane injection project. Some of the initiatives include, as you can see, we've used low carbon concrete for the construction, and the paint that we used for the spray seal. There was a change management done. Initially, the plan was to do a different type of a paint product, which required the application of primer coat. However, we changed that and we moved on to an alternative spray seal, which didn't require the application of a primer coat. So it directly reduces the material usage on that. And we also reused spoil that were excavated during the civil works on the project. We used that for rehabilitation at the end of the project. So we would have disposed of the excavated material and disposed it off in a land facility. However, we managed to store it on site, even though the site was very restricted in storing these equipments. We managed to find a spot and use it to our benefit when we had to rehab some portions of the site at the completion of the project. And we also used off-the-shelf bollards instead of using a specific bollard as per the design. The bollards that we were supposed to use as per the design required a special fabrication. However, as part of the change management, we implemented change management and got approval from the relevant asset engineers to use off-the-shelf bollards, which didn't require any special fabrication. The last one is the leadership and management. As part of this facility, once the facility became operational, or just we hosted a series of visitors, industry, from the industry and from outside the industry, a host of people, take them out to explain about the importance of the Malibar biomethane project, demonstrating the circular economy principles and how the plant operated and stuff. So these are all some of the key initiatives that were implemented during the construction phase of the project. I'll go to the next slide. So some of the lessons learned and key takeaways from the project and with this ISC certification is that there is a general misconception that infrastructure signing up for the Infrastructure Sustainability Council costs additional money, additional costs. However, what we've come across is that it doesn't include additional costs when you're assessing the expenses for the whole life cycle of the asset. Yeah, so that's a lessons learned, one of the key lessons learned for us in this project. And due to constraints, timing constraints, we signed up for the ISC rating scheme only during the construction phase of the project. But if we would have signed up earlier during the planning phase or before the design phase commenced, we could have come up with a lot more initiatives that we could have had a positive impact on, and we could have achieved even a silver rating or a gold rating than what we've got now currently, which is the bronze rating. And the other key lessons learned is partnerships are key to unlocking sustainability. We worked with a lot of subcontractors who worked on the project to get us the rating that we have currently. Happy to answer any questions regarding the rating scheme and how we went about obtaining the bronze rating from the Infrastructure Sustainability Council, and happy to answer any questions, and I'll pause there.
Thank you. Thank you. Thank you for your great presentations. It's now your turn to get involved, and please ask our speakers questions via the YouTube chat box and who your question is directed to. Also, thank you to everyone who submitted questions whilst registering for today's webinar. And we might start there with a question that has come in from Yap, who is watching in Asia. And this question is for you, Jared, Francis Yap is asking, what adjustments do Australia need to do to allow methane to be transported using existing gas lines? Otherwise, how does Australia plan to transport it in a cost-effective manner? Jared.
Yeah, good question. I guess I touched briefly on it in the meeting. I guess the intention with biomethane compared to things like hydrogen is that it is meant to be an equivalent of the natural gas. So, it is designed to be the same, I guess, explosive limits and LELs that we see with natural gas. So when it enters a network as a biomethane, we think that it suits the same criteria that sits in the Australian standards for AS 4645 for the distribution networks and AS 2885 if it's on a transmission pipelines and whatnot. So relatively easy to to blend in once it's a biomethane product. The challenges are definitely around that early stages. I mean, as I mentioned, not all feedstocks are going to be the same. So you need to look at, I guess, testing the amounts of siloxanes, pre-treatments, and selecting the right technology in pre-treatment stages to make sure that you're not introducing harmful, potentially like H2S being a corrosive or something like that into a network could create a risk. But again, that happens in your pre-treatment stage, that the transport of biomethane should be, again, the same as what we transport all of our other methane gases at.
Thank you for that, Jared. And we've had a question, keeping with you, Jared, for now, and then maybe Philippa, you may have a view, that's coming from Yudi, who's watching in WA, asking Jared and Philippa, how will you get acceptance from the wider gas pipeline operators? Any side effects for the existing infrastructure? Thanks for that question, Yudi. Jared.
I'll probably open it up just not to be the pipeline operators, but also the distribution market as well. So from a gas distribution, which is very similar to Malibar, entering a distribution network, it's relatively simple as long as you get biomethane. What I've said before, biomethane meets our regulatory value. It should be easily welcomed and it should be meets that compliance with the customers. Yeah, the challenge is the pipeline operators as well, and most of it will be around the volumes. I guess the production of biomethane at the stage set to our Australia gas demand is quite challenging. I mean, Malibar's is quite a small facility compared to what's the Sydney is requesting in methane. When we start to see those petajoule facilities, so the larger scale production facilities entering a market, they're going to be more favourable and more interesting to a pipeline operator. But then again, the challenge with biomethane will be about the supply and the customer are not always going to be closely located to each other, and that's where pipelines and gas transport companies have always, played that critical role. I think the other one that's worth noting as well is that, these facilities are generally, like for Malibar, it's creating a backfeed onto a network or potentially a pipeline as well. So that redundancy that you create for the customers in there, and that, confidence that they have, in the event of a loss of supply or, peak demand periods, there's going to be a level of confidence that we're able to continue to meet that reliability with our customers as well. So challenges, but a lot of opportunities in, keeping alive a transport network.
Thank you.
Philippa, did you have
Philippa?
Yeah, so the only thing I was just going to add is that us as pipeline operators, we do work pretty closely on this, and we understand that it needs to be a whole of system solution as opposed to individual networks. So something that needs to be understood with gas is that it is all interlinked. The East Coast market is considered one market, and then there's the West Coast market. So from an East Coast point of view, currently, as it stands, you can put renewable gas in anywhere in the East Coast and someone else can pull it out. So what that means is we need to get the biomethane to demand centres, and we need to work together to do that, because Australia has a complexity where we're not actually government owned in terms of infrastructure. So therefore we have private companies working together, and we're starting to do that. So I think it is a challenge, but it is a challenge that the whole gas industry is really leaning into. It's interesting because from an electricity point of view, everyone understands that there needs to be a change and a transition to renewables. And the same needs to happen in some scale for gas, because right now you have large gas production. Let's look at the East Coast, for example, in the north and in the south, and it travels kind of from a New South Wales context. We receive gas from Queensland and Victoria. In a biomethane world, you have plants all across distribution networks. So by there being plants everywhere, places that were typically at the end of a gas line, e.g. distribution networks, become the start, and that's where the gas enters. So there will be changes in terms of gas infrastructure. I think you said, is there side effects for gas infrastructure? I don't think side effects, but there is absolutely a transition that needs to occur.
Thank you for that, Philippa. Jared, we've had a question from Alice, and Alice is watching from Queensland, asking you, Jared, what variety of feedstocks are suitable for this process? Could it possibly be used for organic bio-waste security waste?
Yeah, okay. I guess, biogas, it's feedstocks. Think of the anaerobic digester process as unfortunately that the analogy here will be fun for most, but your stomach. So you eat healthy, you're going to have a healthy output. But you need the right mix of things, of proteins and fibers and whatnot, such that you get that correct output. So where we have Malibar, we have a sole feedstock being a sewage system. It's limited on the kind of compatibility, but you have those other sources. So yes, what Philippa spoke on her presentation. You have from food and drink water processing, the processing residues, agricultural residues, crop sewage, such. But the best will start to happen when we co-digestate. So we take a selected ingredient from there, we get an ingredient from there, and we create and tailor our biomethane to meet that requirement. So theoretically possible, but then we needed considering the processing treatments that happens out of that. If we're going to be introducing elements such as oxygens, then we're going to reduce our ability to run an anaerobic digesters. If there's nitrogen producing elements as well, then we need to introduce nitrogen removal into the facility. These aren't uncommon processing practices. They're very easy, simple to implement, but they also have a economical kind of impact on when does the biogas eventually become too difficult to pre-treat. So we need to keep that in mind. But the other thought as well, and as much a biogas is much easier to pre-treat compared to a solid. We also need to keep in mind that one of those other commodities that we get out of this is a biosolid. So there are acceptable grades in the markets, and that's how biosolids are sold on a grading level, and they have to meet a certain level to be used in certain applications as well. So if we potentially introduce a harmful into a biosolid and it is unable to be used acceptably in a certain industry, whether it's agricultural or state forests applications or something like that, then we're going to end up with a waste product that essentially has that potential to just become a nuisance or a hazardous waste that needs another treatment or disposal as well. So we need to be we need to be conscious of what's getting thrown into the digesters and what that is going to produce out of there. Some really, as I said, 30 years of this in the Europe at the moment. So some really good studies have been done on what potentials the feedstock has to promote methane and other growth. And we need to be considering those as part of choosing our blends of feedstocks.
Thank you for that, Jared. Philippa, and then for you, Jared, we've had a question from Kaushi, watching from Victoria, asking you, what are the key challenges in the Australian market? Philippa.
Yeah, so it's a good question. I think we've got a few. We've got both policy challenges and we've got regulatory challenges. So I think from a regulatory point of view, the issue lies with the digestate. So right now it's treated across most state borders as a waste. And by it being a waste product, it means that it's very hard to spread on land. So we need to look internationally at what they classify their digestate as so that it can be utilized. And the reason that we need it utilized is because it's one of the value streams in the biomethane proposition. So right now we're getting a lot of traction on the biomethane section and policy to support that. But you don't want to have like financial incentives to support an industry ongoing. And when the whole circular economy works around biomethane projects, you end up getting a commercially viable product on its own. So we need those digestate and those regulatory barriers solved. And it's one of the kind of the issues in terms of reaching commerciality for projects in the Australian context. The other thing is political. So from a policy point of view, we've had a lot of traction, as I said, in the last maybe 2 years, and specifically kind of right now, up until last week, having that NGA's recognition of biomethane through distributed networks come through. But from a policy perspective, renewables in terms of the electricity transition, it started in 2001 and gas is only just starting to be looked at to be decarbonised in Australia. So therefore we need policy and we need, first of all, economic support for projects, get them off the ground, allow them to prove concept in the Australian context, and then we can move forward. So yeah, I think there is challenges, but as Jared said, there's a lot of benefits. And the benefits are that, we have 20 to 30 years worth of experience in failed policies and things from other countries that we can look at. We can look at and we have looked at what policies actually make sense, what accelerated markets, what were the drivers, and we can analyze that and not make mistakes that have been made internationally. So we can bring that forth as well. I think it's you, Jared. Do you want to
Sorry,
finish answering your question?
Jared, would you like to comment on that too, about the challenges in the Australian market? Thank you.
Flawless transition. Thank you, guys. No, look, that is a really good one. I mean, the topic that I had of introducing, developing the first biomethane upgrader for Australia, lesson learning, knowledge sharing is great. I love a challenge in a project, but we need to start building a supply chain of bioenergy technology into Australia. We can't rely on Europe. They know what's good for Europe. They have a great foundation to look after their own market, but we can't. We have to develop the industry here. We need to have the technicians in Australia. We need to have our customers requesting, and wanting the product and knowing what the product is as well. So I guess, how is that going to work? I think, Gemina doing projects like Malibar and continuing to, provide opportunities to the Australian industry and knowledge share with ARENA is essential. New Zealand is doing that as well with First Gas's plant up and going as well. So we continue that process as well, but we continue to see other, projects, starting to progress into their design and deliveries. They're really going to mature that bio industry for us in Australia. And then it's, again, the next challenge for that is having that uptake and reliability of biomethane. I mean, the anaerobic digester, it is a natural process. There are weather elements and other contributors in there that may cause issues on the production out of there. We need to understand how that's going to work in the Australian environment, control that, and give confidence in our customers that we're going to be able to provide, a reliable renewable gas at the demand times when they require it. So, working with the stakeholders is going to be key to booming this industry.
Thank you for that. Philippa, Lucas has sent through a question. Lucas is in Queensland. Good afternoon to you, asking, what percentage of the total gas network is biomethane expected to have once this innovation is proven? Thanks, Philippa.
Yeah, so it's a good question, and one we get asked often. And it's kind of impossible to answer at this point because there's going to be a lot of different inputs that will come into play. I think state-based policy is going to be a large part of it, and also feedstock availability. So I know from a Gemina point of view, with our gas distribution network, we currently service about 87, have about 87 petajoules worth of demand on our network. And we think that a pretty good starting point would be the first 30 petajoules. So trying to get 30 to 34 petajoules into our network. And we think we can do that at a really cost competitive price. So that's kind of the low hanging fruit projects that we see that sit within our distribution network. And remembering that from a New South Wales context, we own most of the distribution network, but there's also a lot of transmission pipelines that occur as well. So there's more biomethane to go into those. So yeah, it's a pretty difficult question. I think it will depend on state-based policies. If we look once again at New South Wales, New South Wales has the Renewable Fuel Scheme, which is currently, as I said, a hydrogen production target of 8 petajoules by 2030. It's a pretty good target. So if we could do 8 petajoules, and we think we can do more than that, but under that scheme of biomethane instead, and get it into gas networks, that's, from our network's perspective, about 10%. So if we could get to 10% biomethane by 2030, we think that's very, very achievable. If you look to Victoria, say, as a different context, they're also looking at a renewable gas target down there for biomethane, and they're targeting, significantly less ambitious, but they're looking for about 1 petajoule by 2030. But I think the consultation came back that probably isn't ambitious enough and they need to up that target. But yeah, where we'll land is difficult. I think that there's a lot to come in this space. Once we start, as I said, capitalizing and utilizing the low-hanging fruit, those biogases that are currently already existing and just need upgrading to biomethane, similar to what we do at Malibar, we'll start to progress the industry And then you move into context where Europe's looking at right now, and they're looking at cover crops, they're looking at marginal crops. So those type of crops are those that are really great for energy production, but they're also really good for farmers, for land, for soil regeneration. So, I think the world is our oyster at this point. We haven't even mildly tapped the low-hanging fruit to start with, and then I think there's just growth to come after that.
Thank you, Philippa. Just staying with you, Philippa, for now, we've had a question coming from Kat from WA asking you, Philippa, what policies are needed to unlock greater production and uptake of biomethane? Thanks, Philippa.
Yeah, that's a great question. One we spend a lot of time on. So we think from a policy position, from a federal policy position, we think that there needs to be a renewable gas target or a renewable gas ambition. And by that, it's saying how much renewable gas we're aiming to produce at certain periods of time. And we need one for probably 2035 and then once again for 2050. And the reason we need that long-term signal is because investors need to know that there is a future for gas in this country and decarbonised product. Because no one wants to invest in an uncertain climate when it comes to the renewable energy transition. So we think by the government just setting an ambition, that would be a really great start. The other thing we kind of advocate that could happen from a policy setting is current policies that only are for hydrogen. So at a federal level, we've got things like the hydrogen production tax incentive, which effectively is a rebate for hydrogen production. And we've also got large scale arena hydrogen funding. We think that those being expanded to biomethane, not removing hydrogen out of them, but adding biomethane into them will help the gas transition in terms of the decarbonisation. So we think with those two kind of policy settings from a federal level, it will really start to stimulate the market because it starts to close the gap on the cost to biomethane production versus where users are willing to pay for it.
Thank you, Philippa. Jared, a question from Jason asking you, how safe is biomethane when stored?
So I try to provide that assurance that biomethane is the same as a natural gas. It doesn't exclude it from having the risks, but those risks are detailed document and have a long-standing kind of history of working well in Australia. So the transport of the biomethane is fine. We understand it's a lower level explosive limits. We understand how to, manage a leak or an explosion or something that may ever eventuate in an emergency. That is not uncommon. It's not new. We have worked with biogas as well, but biogas is this kind of there's that unregulated part to it. There could be other contaminants in there. There's VOCs, there are H2S being a toxic gas, introduces a level of kind of risk in the processing stage of the project that kind of, the operators need to be aware of and need to effectively manage as well. So they're not uncommon. These risks exist in our industries. They are quite mature in our Australian standards, but it might be an Australian standards that's not written explicitly for the new industry. And what we do in that stage there is that we need to just recognise it and evolve as they roll out, and we're seeing that happen as I've mentioned before. The AS4564, the natural gas regulatory has rolled out the new revision of that, which stipulates how we're going to measure and control biogas contaminants that and give a limit level of that before it goes into a network as well.
Thank you for that, Jared. Rahul, bringing you into the to the Q&A, we've had a question that's coming live asking you, sustainability objectives being achieved aside, has the project been assessed as financially viable over the asset life cycle? With what sort of financial analysis? Thank you.
Absolutely, yeah. So one thing to be clear is that this is not a demonstration plant, right? So it is commercially viable. It is, as Philippa in her presentation mentioned, it is financially viable, and it's countries in Europe has actually set up um, targets on using biomethane, right? So it is definitely financially viable, and including this project. There are some fine teething issues because it's the first project that we did in Australia, but once those are done, yeah, definitely it's a financially viable project and yeah, industry.
Thank you for that. Philippa, a question's coming from Hari. Great question asking you, how does bioenergy generation compare economically with other green energy sources like windmills, solar and hydro energy generation units? Thanks, Philippa.
Yeah, good question, and really well, actually. So, the bioenergy roadmap, which was created by ARENA and funded by the federal government, was looked at the different LCOEs of renewable electricity energy types. And what they found was for landfill gas to biomethane generation, there's obviously a range, and there's a range for solar and wind and biomethane projects. So, from a biomethane from landfill gas sources, it's extremely competitive, and it actually came out to be cheaper in that report than solar and wind, and still remains to be in terms of a path. When you look at biomethane generated from other wastes, so through anaerobic digestion, what was found was that it is absolutely cost competitive. So it sits in a very, very similar range to solar and wind. So you might kind of hear that and say, well, why isn't it happening? And it's not happening in the Australian context, largely because until, Friday, actually, this week, you couldn't actually use biomethane through networks, so through a distributed system, and decrease your emissions. You had to have the project sitting behind the meter with you. So if you think about probably the first adopters of biomethane in the Australian context will be those mandated under the safeguard mechanism. And by being mandated under the safeguard mechanism, you effectively a large industry. And how likely is it that the large industry will be currently located with the existing sources of biogas, so your landfill sites? Probably never. So, because of that, it meant that now we can use gas pipelines to transmit that biomethane to get it to its best end use. We think that will significantly now support the market to start to develop. But in terms of solar and wind, yeah, super cost competitive, especially at the lower end. Um, Obviously, the more higher cost end of biomethane sits around like agricultural crops, and that's because you've got to actually get the feedstock from the farmers, from the crops, bring it to the project, and then anaerobically digest it. So that's the more expensive form of biomethane production. You also get some economies of scale at that level, though. And then, yeah, the cheapest is definitely landfill gas generation with your sewage plants as well. And that's because the biogas exists. And what we mean is the biogas is already there. You don't need any further anaerobic digestion. So, from that perspective, currently biogas around 70% of it's wasted in Australia. So that's pretty crazy. It's an absolute energy source that is solely flared and burnt. And that's actually incentivized in the Australian context through the Australian Carbon Credit Unit Scheme, so ACUs. So it's an interesting place, but yeah, super cost competitive.
Thank you, Philippa. And just staying with you, Philippa, for now, we've had so many questions, which is great. Philippa, we've had a question from Hamid asking, is it correct that the byproduct or services of the process for making biogas are more valuable than the biogas itself? Philippa.
Yeah. It's hard to say, and that's because we don't have established markets yet for any of it. So we don't really have an established biomethane market. We don't have a biogenic CO2 market in Australia. We don't have digestate. I don't know that they, a lot of different project producers we talk to right now, they think, yes, the commodities will be more valuable than the energy. But right now we think everything will kind of play its part. And if you look at it from a value proposition of a total project, you need all the commodities to be commercially viable against their kind of nearest competition. So once again, digestate, it will replace fossil fertilizers. So fossil fertilizer cost base, and you've got to look at energy content when you convert it, but effectively that has to be commercially viable there. Biogenic CO2 needs to be viable from the against fossil CO2 and the existing CO2 market. And then biomethane needs to be commercially viable as well. So yeah, hard thing to answer in a context where neither of the three markets really exist in Australia yet. But yeah, I think there's a lot of value add from all the streams that benefit from the circular economy of biomethane generation.
Thanks, Philippa. Jared, we've had a question from Shane asking you, is methane extraction safe given that it's explosive? Jared.
Explosive limits and hazardous area are just one of the challenges that you'll have with biomethane upgrading. The toxic gas was probably the more challenging for us. I mean, working for Zimfer and Gemina, we're quite accustomed to working in that hazardous area, particularly around natural gas. So we had a really good foundation of safe working systems in place to manage those risks, and you'll find that that's quite existing with anybody that works in that part of the industry. We challenged ourselves when we started introducing ourselves to the other areas that aren't as prominent. For example, the H2S. I mean, yes, toxic gases do exist in a bit of our infrastructure, but they're not as frequent and at the levels of what we saw of Malibar. So where we did come across that challenge as well, we relied on our stakeholders and partnerships, particularly with Sydney Water and other gas producing industries as well, to take into account their best practices, revise our own strategies, and implement new safe work systems into ours, and then train up and upskill our workforces to work safely in that environment. But this is how most and any energy transition project that's happening at the moment is going to come across those challenges. It's just having the right mindset and a good team to support you in that transition as well.
Thank you for that, Jared. Philippa, a question that's come in from Darmid asking you, one of the big questions is the use of domestic biomethane production and consumption on individual scale, like rooftop solar. Philippa.
Yeah, so I think currently we would think no, it probably won't be utilised at that level. And that's probably largely volumes wise. So you'll probably never get enough organic waste at your household to make your own anaerobic digestion process and then use biogas yourselves on site. What we do advocate for is councils. So if you think of your local council, and some of you might live in councils where you currently segregate your food and organic waste, and if you do that, the use of that waste is what can be that waste can be utilized for biomethane through anaerobic digestion. Currently, a lot of those organics that sometimes are separated and sometimes aren't, depending what council, what state you live in. Those that aren't separated, that combined litter goes to landfill, and that's where we get landfill biogas generated from those organics that sit within landfills. You get natural anaerobic digestion there at landfills that then often is flared or used for electricity generation currently. But other councils that do separate their organic waste often that organic waste currently, sometimes it's dumped, so it's just put into old mine sites, and other times it's used for composting. And composting is not a bad use of those organics. However, it doesn't use the energy out of them. It gives you the digestate / the compost, but it doesn't give you the energy. So what we're advocating from a council perspective is when they do look to get people to segregate their green waste, they look at actually utilizing that for its highest value end use. And that is using the energy within the waste before you get to the digestate stage. So yeah, I can't see us having mini anaerobic digesters at our house, but absolutely utilizing household waste is one of the cheaper forms of biomethane generation.
Thank you, Philippa. We've had a few questions on similar themes, Jared. James has asked us a question, what is the efficiency and energy output when using this process as opposed to cogen, or is it an also and case? And thank you to Sergio, who's asking you, Jared, how much heat can be recovered from the compressors?
Yeah, good ones on efficiencies. I guess the theme here is that we're utilizing as much of the process and circular economy as possible. So the first one on the processing efficiencies there, it's about 0.3 kilowatts per newton meter cubed of the biogas in the energy. A lot of that is, this is specific to our plant. Our largest demand of electricity consumption in the facility goes to the 400 kVA electric driven motor for the compressor. So that does go up and down based on your production rates, but we did test it in our commissioning stages there over a range of scenarios, and we found that those results were pretty consistent with what we were expecting, which is a really good outcome. The other one is on the heat recovery as well out of the compressor. Unfortunately, it's not one of the commodities that we reuse, but there is a capacity there about 0.25 kilowatt hour thermal per newton meter cubed of heat that can be reused in other applications. And I say, best ones of those are going back to the anaerobic digester, or where I've seen it in colder environments as well, is just simply being used to look after the heat of the facility. But it'd be great to even see that implemented into greenhouses and other thermal kind of demanding facilities as well.
We've had a question from Sergio asking you, would it be better for someone like Sydney Water to use biomethane in-house to generate power for self-use? Thanks.
Yeah, certainly. But in this particular site, Sydney Water already has a cogen unit, and they use the energy that's generated from the cogen unit to power up their facility. So there's no requirement in this particular site. So we getting injected into our network.
Thank you for that. And I think we have just time for a couple more questions. So I'm going to start with Philippa, talking about incentives, and then Jared to talk a little bit about a safety question. So Philippa, we've had a question from Prakash, who's asking, what are the current incentives and other supports that are likely a biomethane developer may obtain? Otherwise, projects may not seem financially viable. Philippa.
Yeah, it's a good question. So right now, there's not a lot of financial incentives available to biomethane projects. I think that will likely change very soon. So a lot of those incentives are looking like being state-based at this point. So as I said before, the Renewable Fuels Scheme from New South Wales perspective, it's an 8 petajoule hydrogen target that will likely be expanded to biomethane, and New South Wales DQ tell us that that will be mid-year, so any day now. Right now, what that is in terms of an incentive is a $25 a gigajoule incentive for every gigajoule of hydrogen that's produced. Whether that incentive will remain that high for biomethane if it is added to that scheme remains to be seen, but there's likely going to be an incentive for New South Wales biomethane production come thereabouts mid-year under the Renewable Fuel Scheme. Similar, the Victoria Renewable Gas Target will also have an incentive scheme. They also have stayed very quiet in terms of what value that will be at, but it will likely occur. And as I said, from a federal point of view, we believe that there probably needs to be some form of federal support. And right now, the hydrogen production tax incentive is set at $2 a kilo for hydrogen. So we'd like to see that similarly transferred to biomethane. And I think from the top of my head, that's about a $16 a gigajoule subsidy. So yes, I think subsidies will absolutely be needed for the projects really to kickstart and us to exponentially grow our market, as that's what's been seen internationally. But we do think that there is a path for incentives to come off and the market to exist without them in terms of the long term.
Thank you, Philippa. And Jared, just our final question, and thank you. We've had so many questions, and apologies for not getting to them all this afternoon. But our final question is from Stephen, asking you, Jared, what key safety skills and training should organisations interested in exploring biomethane generation prioritise obtaining to ensure they can safely explore these opportunities? Jared.
Yeah, I guess I mentioned the scenario before about how we're quite mature in how we manage our hazardous areas and working with live gas, particularly at high pressures. So we had that existing safe work system in place. So from a gas transport company as well, I'd say that we needed to focus more on how to manage the toxic gases and also a bit more familiarity on working in the low pressure systems as well. That's going to be completely different for somebody approaching it maybe from a wastewater or a waste kind of avenue as well, where they're quite acceptable and aware of the challenges of toxic gases, low pressure systems, condensates, and the other biological hazards that exist. But when it comes to the higher pressure systems and managing that hazardous area and the compliance for the electrical equipment and whatnot, they're going to be exposed to some challenges that don't exist in their existing safe work systems. I recommend, if that is the kind of industry that you'd be coming from, that you'd be working with industry. And the next one that I reckon is once the systems are implemented as well, they're doing cold eye reviews and third-party verification audits as well prior to any operations and continuous improvement as you progress on your operations. Again, we're learning a lot with introducing biomethane, and even now we continue to improve our own practices and update new systems as we go.
Thank you. And it is all we have time for today. So please join me once again in thanking Philippa Minton, Rahul Daraj and Jared McKins for their time and input. I'd also like to warmly thank Engineers Australia Industry Partners Infra for their support. Quickly, we're pleased to share that the Australian Excellence Awards nominations are now open. Help us recognise the people and projects driving innovation. Nominate yourself, a peer or a standout team by scanning the QR code. As always, we're looking for feedback. So if you don't mind taking a couple of minutes to complete a short feedback form, which is linked in the description box below, helps us improve and plan for future sessions. Thank you for joining us this afternoon, and I look forward to seeing you at our next Industry Partners event. Thank you and good afternoon.